All right, ladies and gentlemen, we're back. In the last video, we talked about angle bisectors and segment bisectors. So we did a couple of examples of using those concepts. Now we're going to be talking about it in terms of proofs. So let's start with example number 2. Given that PT bisects QS, QS bisects PT, we need to prove that triangle PQR is congruent to triangle TSR. All right, so let's write our statement. We got our statement. So our first statement given is PT bisects QS and QT bisects PT. So under reasons, we need to write given for our first one. All right, our first reason will always be given. Sometimes it'll be the first two, but in this case, it's our first reason. All right, so before we get started of the other statements, we need to start marking stuff. So let's talk about PT bisecting QS. So PT is going from upper left to lower right. So what that does is it means that this is congruent to this, okay? And then QS bisects PT, so it's basically going the opposite way. So this is congruent to this. All right, so we marked those. So we need to talk about those segments that we just marked. So the first one, it does not matter the order, but I'm going to go with QR is congruent to RS. And that is, and the reason for that was because remember, it bisected a segment. So it bisected a line, so we're going to be definition of segment bisector. All right, that's our second reason. Now the order of number 2 and 3 didn't matter the order of. I just chose to use QRRS. I mean QR is congruent to RS, but I could have used that for reason 3, and then use the reason for 3 for number 2. But we're going to go in this order. So PR, is congruent to RT. And again, because it's again definition of segment bisector. All right. So that takes care of that. So the last thing we need to look at is we only have 2 things marked. Remember, for congruence, we need 3 parts. So we look back at our picture, and if you turn your head a little bit, you'll see something that Mr. Harper likes to wear on his formal days, aka Mondays and occasionally Tuesdays. You'll see a bow tie. So remember I told you that we cannot label it just angle R because we have an angle on the top and an angle on the bottom. So we need to more properly name it. So remember I told you when you're doing your vertical angles, you always want to list your R or your vertex as your middle letter. So we're going to start with the top one. We're going to say angle PRQ is congruent to angle TRS. And that's basically what this is saying here, okay? So, and I just said the reason for this is vertical angles. So that's our fourth reason, okay? So now, remember, we had to prove that these triangles are congruent. So again, we can just rewrite that statement, which is triangle PQR is congruent to triangle TSR. Okay, so making sure our angles and sides match up. So this is congruent because of, look, we have a side, an angle, and a side. So we have side, angle, side. So that's going to be SAS. And now we've successfully proven that these 2 triangles are congruent because of side, angle, side. All right. So now let's move on to our example number 3. This symbol right here looks like an upside down T. That means perpendicular. We haven't really talked a lot about it. I'm sorry, I'm not spelling perpendicular right. Sorry, guys. So again, this symbol right here is perpendicular. And that means it forms a 90-degree angle, and we're basically going to draw a 90-degree box. All right. So let's go ahead and start doing our statements. Our first statement is BC is congruent to CM. I'm not congruent, I'm sorry, I apologize. It's perpendicular to CM. MN is perpendicular to CM. And then lastly, D is the midpoint of CM. So all of those were originally given to us. All right, so we're trying to prove the triangle BCD is congruent to triangle NMD. All right, so now we move on to our second. Well, first of all, we need to mark our parts. So we said that BC, which is here, going from up to down, we're going to put a mark here. Let's say that's 90 degrees, okay? And then MN is going to be our box on this side. All right, so we got our two boxes. Now, remember we got the last part, which is D is the midpoint of CM. So that means if it's a midpoint, it breaks up into two congruent segments. So we got one here and one here, okay? So now we look at our second statement. This time our statement was given to us. And here we talk about what I just talked about, perpendicular. So we would say definition of perpendicular. Now you don't have to do the upside down T, but just so you can see, that's basically the reason why. That's the reason for that one. Now we gave you reason 3 because we had not talked about right angle congruence, but basically all it's saying is the angle BCD is congruent to NMD, meaning that if you have two right angles, 90 equals 90, so they're congruent. Okay, if you have an angle that equals 47 degrees and another angle equals 47 degrees, they're congruent. Okay, so that's the same concept here. It's just specifically called right angle congruence. All right, our fourth reason. Now, there's only one thing. Well, we have two more reasons that we could have switched out, but we're going to go ahead and go with what we were given. So the best thing to do, guys, is before you get into your reflexive or vertical angles or alternate interior angles, do state the things that you marked. Okay, that's what these statements are. Everything you're marking. Okay. All right. So our next thing that we marked was DC is congruent to DM. So we would say CD is congruent to DM. And not DM like DM on social media. All right, so here, because the reason why we mark these as congruent, because we said D is the midpoint. So whenever you see words like midpoint or bisect, that's going to be part of your reason. So here we'd say definition of midpoint. Okay, so now we got our next to last statement. Now, again, just like in the last one, if you tilt your head a little bit, you'll see something that Mr. Harper likes to wear on his formal days, a bow tie, aka vertical angles. So we're going to say these two angles are congruent. And remember, we can't say angle D. We got to properly name it. So we need 3 letters. So we're going to say angle BDC is congruent to angle NDM. Notice my angle D, the D is in the middle because that's our vertex. Okay, so we're going to say that is because of vertical angles. All right, and then we just rewrite our proof statement, which is triangle BCD is congruent to triangle NMD. And let's see why it's congruent. We have an angle, a side, and an angle. So ASA. All right. So that concludes using proofs to prove bisectors, either angle bisectors or segment bisectors. Now, we didn't do any angle bisectors in this one, but in the next video, we will do some angle bisectors. All right. Thanks, and I'll talk to you in the next one. Bye.